So we've spent a bunch of time in previous videos in drawing the mechanism for acetal formation. We saw that you form these acetals when you have some sort of carbonyl, ketone or an aldehyde, and then you mix it with excess alcohol, at least 2 equivalents of alcohol. And we drew the whole mechanism. And that's one thing that hopefully will make these reactions not seem just like random changes of letters. You'll understand the flow, the journey of a reaction through opposite charges attracting. You can turn one thing into something that looks very different through those processes. Another skill is to step back after you understand how reactions happen, to step back and to think about how you can use them in larger synthesis exercises. So not so much to think about how the reaction is happening, although that should always be there in the back of your mind, but to think of what you can do with that reaction. And that's what exercise 2010 is trying to get you to exercise. Just trying to get you to think of that same acetal formation, but in the context of synthesis rather than of mechanisms. So here, if you had this ketone, let's say you made that through Friedel-Crafts acylation, right? You had benzene, and you treated it with an acyl chloride and aluminum trichloride, AlCl3. So you have this derivative. What can you do with it? Well, what if you had catalytic acid and excess methanol? And you should recognize that as, oh, here's a ketone, here's excess alcohol, I'm going to form an acetal. Now, we're not going to draw the mechanism here. We're just drawing the acetal you would form. So if we'd have the same carbon chain, we're going to replace this oxygen with 2 bonds. And they're each going to be to the MEO, right? We've seen how the proton transfers take the hydrogens off of these, and you just get the 2 ethers. So here we get these 2 ethers bonded to the same carbon. That's our acetal. And so that's the product. That's it. You would end up getting this. And you could see how you could use this type of a recipe if you wanted to do this transformation in a synthesis problem. So similarly, here we have another example. What if you had that same acyl group on the benzene, right? So let's say you did a synthesis and you had already treated a benzene with like this and AlCl3. That would put that carbon chain onto the benzene, so Friedel-Crafts acylation. So now we have this, and what can we do with that? Well, one thing we can do is react it with alcohol, so we have a ketone. So we can do acetal formation. And in acetal formation, we're going to replace the 2 bonds here with bonds to each of these oxygens. So you can imagine the carbon chain is going to stay the same, but the carbon that had the carbonyl on it is now going to be bonded to 2 ethers, so oxygens. Now notice how many carbons are in between these oxygens, 1, 2, 3. So that means we need to have 1, 2, 3 in between them there. 1, 2, 3. And that is an acetal that you could form. So that is a synthesis. You can use that in synthesis. If you had to make that, you know how to make that. You just have to add a ketone and 2 equivalents of an alcohol with some catalytic acid, and you can get this done. This should have these benzene pi bonds in there. So this exercise is a short one. You're not having to draw the whole mechanism. It just wants you to predict the products. It wants to get you to think of acetal formation in the context of synthesis problems. And you want to do that now while it's still fresh in your mind, because by the end of the chapter, we're going to do it as one step in a multi-step synthesis. So I just wanted to get you to think of these same reactions that we're drawing the mechanisms for, but in the context of synthesis.